All right, so today we're going over an 820-3437 airboard. This has already been ultrasonicked, but the stated problem is that it is dead, so you get no light in the charger. No light in the charger. Now, the reason for no light in the charger is usually the PP3V42 circuit. So to give you an idea on a motherboard where you can actually see it on the schematic, what that circuit is and what it does, this is the last time I'm probably going to explain this since I've explained it in 60 other videos. The one-wire circuit is U6901. Here we go. All right, so this over here is the adapter. This is where the adapter comes into the machine. This is on an older motherboard. So this is 18 volts going through to the machine, and this over here is the line called adapter sense. Adapter sense attaches to this chip. This chip, the adapter sense line from the charger, the adapter sense, attaches to X for external. Then there's internal, where that chip is going to take that same signal and send it out cis1 wire on a bidirectional data line to the SMC. Right over here. See where it says bi? That means bidirectional data line. Now the SMC needs to talk to the charger for it to turn on. So let's go back to where that was, the cis1 wire line. Now what turns this chip on? Every time you see VCC, VDD, or anything like that, you're going to see, you know that that is what this chip needs in order to actually be powered or turned on. So the VCC pin for this, and also the pull-up resistor for the data line for cis1 wire. If you don't know what a pull-up resistor is, either what is a pull-up resistor and how does it create a data line video, that is created from this chip. This is a logic gate. The way this works is when it sees SMC, BC, ACOK come in, when that comes in, then PP3V42_G3 hot, which is a 3.42 volt power line, will be let through to this chip, and it will turn on. Without PP3V42, you will get nothing else. Now, the airboard is a little bit different because the one-wire circuit on the airboard is on the DC inboard, and we don't get a schematic for the DC inboard because Apple sucks. So we just have to assume, based on the older circuit idea, that we still have to deal with the one-wire circuit, and that's still requires PP3V42. So when I go to search for cis_1 wire on this board, here we go. So cis1 wire is on this J9500. J9500, which you can't see because I'm on the wrong capture. Cis1 wire goes to the DC inboard. So J9500, when you go to the board view software, J9500. Yeah, that's the connector for the DC inboard. And there's also PP3V42 somewhere going to the DC inboard. So let's just look for that. Yeah, you have SMC, BC, ACOK going there. So you know that the one-wire circuit has to be on that side. You need SMC, BC, ACOK to be present in order for the one-wire circuit to turn on and allow the charger to talk to the SMC. And you have PP3V42_G3 hot going there. This is one wire. So let's see if PP3V42_G3 hot is present on my board. So since that's needed for the one-wire circuit to work and to get a charger light. So that's supposed to be coming out right over here. So when I check that on the board, that's going to be over there. I'm going to take my multimeter in diode mode, put the red probe on ground, put the black probe where PP3V42 is supposed to be, and I have a 0 ohm short to ground, which means that it is shorted to ground by something. So you have to figure out what that is because PP3V42 won't be present if it's being sent to ground. And also, if you look in this area, it doesn't really look the nicest. It looks like there was corrosion there, even though it has been through an ultrasonic cleaner already. So let's just zoom in on the microscope, turn the light up a little bit so you can see. Not the nicest thing in the world. Now, the funny thing here is, even though this area is covered under this underfillish-looking nonsense, they were still able to get damaged by liquid. So this didn't do anything. Nice try and pretending to be Lenovo. Your stuff was not waterproof, and it never will be. So let's remove that. We just have to heat it up a little bit. And then I'm going to attach a wire there, and we're going to see what gets hot. Since the short to ground is so immediate, I'm pretty sure it's going to be something obvious and something that's going to get hot really quickly. Whoa. I almost burned my microscope. Okay. I hate this junk. This doesn't do shit. It's just it's just annoying. All right. So let's see where the short is. So we have to inject 3 volts there to see where the short is. So let's take my power supply wire. and blow up the board. So I'm going to put solder on a screw hole. I know. I'm sure there are more professional ways to do this, and I'm sure that a lot of people will say that this is not professional, and I'm also certain that I won't care. So let's do this. So I'm going to take the ground. And shove it in there. I don't care about the quality of the soldering there because it's not like that's going to stay there anyway. I'm going to take this area over here where 3 volts is supposed to be and 3.42 volts isn't. Again, not giving a crap about the quality of the soldering. This is the purpose of this. You have to realize is to blow something up. It's not a permanent repair. So I'm not going to waste time on those things. Now I set my power supply over here to 3.42 volts. Voltage 3.42. Current. A lot of people ask why I don't limit current, and makes it harder to find things. All right, so let's see let's see if it's obvious. So what gets hot? What gets hot? What gets hot? Now, a little guide here. What's going to get hot has to be something that is PP3V4 too. So these are the potential things that could be getting hot. I should rotate this so it's the same way as the board is on the desk. You guys see anything that looks suspicious? All right. This is going to be fucked even after that. I can just tell from what it looks like the SMC will likely need replacing. Whoa. Okay. And the short is gone. Alrighty. Now, keep in mind that the short was on 3 caps that go directly to the SMC. So what do you think is going to be screwed next? Oh, yeah. This will be no fun. Okay, so we're going to take those 3 caps off of the donor board and pray that the SMC is good, which it probably isn't. Are you still recording? I can't read that. There it is. I really can't read that. Common sense prevails. Wrong tip. Now the pads are kind of messed up, so it's going to require some scraping to make them work again. Worst case scenario, we can just break that trace, run a wire to the capacitor, and just do that. You'll feel it in your hand when you're scraping it versus when you're not. So in the beginning there, I wasn't scraping a damn thing. And I couldn't feel it, and I also noticed that you couldn't really see any solder getting on the pad. But now, it's scraped, and it's good. You're also going to see that there are some burned resistors to the side. Those at this time I don't care about because I know that those are actually for, those are for, you know, that's for Apple. That's for programming the SMC using that little connector on the other side of the board that we'll never ever get to use over the course of our lifetime. I don't give a fuck about programming the SMC because I don't get to do that. If I want to fix the SMC, I have to take it off of another board and attach 96.25 millimeter balls to it. Oh yeah. So I don't give a shit about those resistors. They're for something I don't get to have or play with. I just flew something right off of the board. I'll have to put that back on. Unless it's for programming the SMC, that is. In which case I won't. The cool thing about the flux and the hot air is that it's going to put everything into place so it doesn't look like I screwed with it, and everything is going to be aligned perfectly, even if I did aligned it really badly. So let's see what that little this thing is over here. Is this important? U3710. That's for the SSD. Yeah, we're going to assume I got to put that back on. All right. There are certain things I don't care about, like programming. That thing to program the SMC while the SMC is on the board, that's not something I'm ever going to put back on if I or waste time on. Ready? If I were smart, I would be seeing if the board actually works at this point and care about the SSD thing later. But I know that I'm going to forget to put this back on later. And this board will come back saying, it works, but I get a question mark folder all the time now. You happen to know why that is? No? I have no idea. It's a bunch of little balls shooting out from under the chip. That's a sign of quality soldering right there. Oh, you missed that. It's a good thing you missed that. I have a chance to correct that before you ever see it. Yep. Come on, move out where I can catch you. Okay, so a bunch of questions to answer here. Is my SMC any good? No idea. Is my PP3V42 rail going to work now that I removed the short? No idea. Is the rest of the board going to work, even if it turns on? All good questions and all stuff I'll be able to answer in a few. All right, so I get a green light. Now for the next test. This is the most important one of them all. There are some places before we started doing this that we were outsourcing boards to, and the reason this is such a long-running joke is because they would go on and on about all the procedures that they use to test boards. My personal favorite excuse, we sent a board a long time ago to this place that wasn't booting into the operating system. and that's what we sent it for. So they sent it back saying that it was fixed. And it's still dead. Anyway, they sent it back saying that it was fixed, and it just still didn't boot into an OS. So eventually, after a few months, we managed to root out of them that what they did is they booted it into Windows 7 because for some reason it wasn't booting into Mac OS. And because of that, they said it was fixed. And it's like, you really do just like when the fan spins, you guys are done. So that's why we have this running joke that when the fan spins, we're done. All right, so it's still not turning on. So now we have to go through the power rails and see what's missing, and I also want to see what state the computer itself is in. So is the machine entering an SO state? Now, as I said, on the newer Air boards, this is one of Apple's ways of just making things harder, I think. They used to have all the power diagram and all the test points on page 1, 2, or 3 of the schematic, which kind of makes sense because that's what the first thing that you should check for. Let's put it on the first page. Now, all that information is on page 64. You fucktards. All right, so here we go. So what I want to do here is I want to see what state the machine is entering. S5, S3, SO. So it could be that the machine is actually trying to turn on, but there's one power rail missing, or it could be that it's not trying to turn on at all. So if I see that S3 power rails are missing, or then I know that it's not even trying to turn on. But this machine itself is supposed to try to turn on as soon as you plug it in. All the Core i5 and Core i7 series MacBook Pros, when you plug the charger into the machine, it's supposed to just come and turn on, which means entering an SO state. So S5 is off, S3 is suspend when the little light is blinking on the front, and SO is on. So let's see if my SO power rails are present. So let's just see if, let's find an SO power rail. Let's say PP3V3 SO. Let's see if that one is present. Windows 8 scaling sucks. All right, so let's turn this around. So where can I measure PP3V3SO? This software could cause brain hemorrhaging. Oh, yeah, let's check over here. .056. Huh. Interesting. Let's try another SRL. PP5ESO. I would expect it to be there or not be there, but not be there partially. Piece of crap. So PP5VSO is not there. All right, so it's not even trying to enter an S5 state. I mean, an SO state. Where there's a corrosion on another part of this board here. Yikes. That's not good. All right, so let's see what these things are for. I'm pretty sure that's for the 5-volt rail. Let's go back to, I don't want to see that. R7539, what's that for? Delete that. R7539. It's supposed to be 20 kilo ohms and it's 20 kilo ohms. So before I go troubleshooting this, because this is the chip that creates PP5V S4RS3 and also PP3V3 S5, before I troubleshoot any of this, because this could wind up being a total waste of time, Let's see if they're being told to turn on. Let's also see if they're present. So PP3V3S5. Because again, as nasty as all that stuff looks, if it's actually working, then that's not the area to be looking. PP3V3 underscore S5. Okay. So that's chip I was looking at, and this is where I'm going to see it, I imagine. All right. But remember, to measure voltage, put the black probe on a screw hole and the red probe on where you want to measure. So PP3V3S5 is not being created. Now PP3V3 is one of the power rails that's going to be used by the PCH for a certain logic. So if PP3V3S5 is missing, it's not going to try to enter an SO state because it can't try to enter an SO state. So let's see what the enable is for PP3V3S5. Let's see why it's not turning on. So PP3V3S5 underscore EN underscore R. That comes from S5 power enable. S5 power enable comes from SMC. Boo. All right, let's see if SMC PMG2EN is there. There. Yeah. You missed that section. So EN2 for PP3V3S5 goes through R7552. So there's going to be voltage that comes to this chip over here to turn on that rail. And remember, I'm not going to troubleshoot this entire cluster fucking mess and test every resistor and transistor before seeing if the rail is even being told to turn on. So we go to S5 power enable. And S5 power enable here comes from the SMC. You saw what my SMC area looked like before, so nah. Let's see. Please don't be the SMC. Let's see. Is that signal present? My SMC is partially functional. You have to keep in mind that at least it's getting something because I have a green light, but it still could be bad. So let's see. Where can I get that? No, I don't want to use my multimeter to run the ball into the SMC. How about here? That bottom resistor. Yeah, you. All right, let's measure. Let's have the charger plugged in. It's very easy to start seeing 0 volts everywhere because as I'm moving the board on the desk, I forget to plug the charger back in. Thank God. All right, the SMC is producing it. Oh boy, that would have sucked having to reball that. Okay, so where does this go next? So I check the beginning, and remember, I don't like checking one point, then here, then on and on. I like to check the beginning and the end, and then I'll go to the middle if I need to. So let's check and see if that is actually getting to my chip. So on pin 1 of R7552, that should be there. I have R7552. Well, that doesn't look nice. Which point on this do you see the biggest red nasty shit? See, on the board view, this is where I'm checking. And on the schematic, this is where on the actual physical board itself, this is... Okay, so the 3 volts is making its way to the chip. So now I know that I can start suspecting the chip because the chip itself is being told to turn on. I can start suspecting the chip or a component in the associated area. Remember, again, if the chip is not being told to turn on, you don't replace the chip that makes 3 volts just because you don't have 3 volts, because very often it's not being told to turn on. So let's see. So now we start to look at the area that's corroded and try to figure out what is most likely messed up there. So let's see. Board view. R7539 we looked at already. That was 20 kilo ohms. What's next to it? C7539. Let's see if it's actually possible to get a data sheet of what everything on this chip does. So this is TPS 51980A. Let's make a new window in Chrome. What do you think the chances are that we can actually find anything on this? Yeah, there's bullshit. All right. No, not much we can do there. So let's try to guess what this does. Comp. All I can guess is that it's comparing something from the reference voltage that's created by the LDO inside the chip over here to, but it's comparing it to what? So comp 2. So one pin of the chip is attaching to another pin of the chip, but what for? Oh, well, okay. So at this point, we're just going to turn brains off and reserve the brains for later because I don't have a data sheet and I don't feel like driving myself nuts. So we're leaving brain mode and we're entering monkey replacement chip mode. So let's just... Wait. We take this. Goodbye. 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 Sayonara. Alrighty. What a nice big mess. With a my mess has a capacitor in the bottom of it too. Look at that. All right. Now this was not a 10-second repair. Now I can charge you more than $200. I'm thinking 400 maybe.
That wasn't the agreement.
Let's ask Steve what the agreement was. That's it. Well, this is going to be a mess, but I don't. Oh well. All can be fixed. That was atrocious soldering. Fucking atrocious. That was it. And it's just going to get worse. Look at that nice big solder ball. I saw where it went. I also felt where it went. It hit my pinky as it was running off of the board. Look at how fast this thing gets hot. SMC PM G2EN was on this board, meaning that my SMC was not bad. God is good. For the most part, God is good. It would have really sucked if the SMC were bad. But sometimes, just sometimes, he kind of smiles and gives me a working SMC. Fuck. It ran away. This thing is too damn small. Like, look at that thing. Look at the size of the tweezer and look at the resistor. It's ridiculous. What? Nice try. Fucking bullshit. It's already gone before I even got it there. It's already gone. Probe points where you can test. Oh, this is awful. That looks like a kindergartner did it. That's the beauty of Amtech 559. You see that? Now look, it went from kindergarten to professional. Hey, nobody looking at this has to know that I suck. Oh boy. That looked nasty at one point, so I'm interested in seeing what that is. Right here. That's where PP3V42 underscore G3 hot comes into the chip to create S5 power good. The reason I'm interested in that is because that power rail was missing, and that was the one that had the fluctuations on it because of the short to ground. So it makes sense that that's corroded. And I'm going to check and make sure that that is present on the other side of this. Because here's the other thing. So I was looking for enables, right? There was actually a very good chance that that resistor that I didn't check was the one that was bad and the chip was good. So even though the chip was being told to turn on, watch, even though this chip was being told to turn on, before it will actually turn on, it wants to see that a power good signal is present. So there are different power good signals at different points in the machine. For example, let's say on a Retina board, the PCH will want to see PM PCH power OK come in. If it doesn't see that, it won't turn on the machine. And over here, that resistor is for S5 power OK. So the way this works is the S5 rails won't turn on without PP3V42 underscore G3 hop coming up. Sequence is also important. So let's see. So that's R8141. See? S5. Nice try, Open Broadcaster. I said S5 power good. That goes to the SMC. And it also goes to this. Stop changing the screen. And it also goes to this chip. Actually, it doesn't go to this chip. It comes out of this chip, I guess. I guess PP3V42 is a pull-up for it. Either way, without that there, you're kind of screwed. So I didn't do a good job of explaining that. So let's just clean this area a little bit. Bunch of... Put it in focus so you can see. So I just I had some flux there, so I just heated it. And it moved a bunch of small components that I poorly soldered back into place. Let's clean up some of the shorts from the poor soldering from before. There's a short on that side I saw. This side wasn't really soldered that great. Okay, that short is cleaned up. This side is soldered on. Yuck. What have I done? The thing I'm using to clean my soldering iron has more solder on it than the motherboard does. Nah. All right, let's see if we have any changes. And also, since I have PP3V4 too, I can finally remove these wires, power supply wires from the board. So that means I get to charge more.
No, it was either 10 seconds or now you get to pay the 3.5.
Yeah, retail. And we're done. So let's go over what got fixed here. First, PP3V42, which is the main power rail required for the one-wire circuit, was shorted to ground because of capacitors by the SMC. After that was done, all the S5 power rails were not turning on. It could have been because the chip was bad. It could have been because that little resistor that I replaced was bad. Sometimes I don't really care what the actual problem is. I just care about solving it as quickly as I can. So once I saw that that area was corroded and that my S5 rails were not coming up, well, first I saw that my SO rails weren't coming up, and they're supposed to. So I started looking for the ones that were higher, like the S5 ones. The S5 one wasn't coming on, so I checked the chip that controls the S5 rails. It was receiving the enable signals to receive those S5 rails. The power good signal was not coming out of the chip. So at that point, you kind of blame the chip and the things around it that are corroded. We replace, and we're good. Again, do I need to test this any further? Is there anything I have to do? Like boot it into Windows and say that it's good? Not even that. The fan spun. We're done. All right, so this is what that same motherboard looks like after the ultrasonic cleaner. So this is the TPS 51980 area. I'm not going to say that it's perfect, but as you can see, even though I'm really, really bad at soldering small components, all I really care about is that I get the component on the board. Once it's on the board, I don't care how straight it is. I'm going to use that Amtech 559 and hot air, and it's going to move it into place, so it's going to look like I'm perfect at soldering. I mean, really, this has a very factory-ish feel to it. You would have no idea that a complete idiot worked on this motherboard, which is pretty cool.